Hello, hello, hello. Today is Thursday, December 15, 2022. It's early in the morning for me, 6:37. I just woke up. Solutions to problem 159. And I mentioned earlier that I consider this an easy high school problem. But of course it always depends on which high school you attended. So solutions to problem 159. Answer to A. With the switch B open and switch A closed, C4 is out of the picture and the circuit is effectively as shown in the diagram at the right, this way. If V, the potential between here and here, is 120 volts, of course that's the battery voltage, then we must have that V1, V2, V3 is V. By the same sort of charge conservation argument, all three capacitors must necessarily have the same charge plus and minus Q on their plates. Since all three have the same capacitance, which we call C, we have that Q is CV1, CV2, CV3. Therefore, V1 is V2 is V3 is V over 3 is 40 volts, 40 volts. Oh, I would say 75% of the answers have A correct, maybe even more. Once the capacitors are charged in this manner, the potential across each will remain the same even after the opening of switch A. So now we go to question B. Opening switch A has taken the circuit branch containing the battery out of the game, but not before charging capacitors C1, C2 and C3 as described in part A. Now closing switch B brings C4 back into play, and the circuit is effectively as shown at left. C1 and C3 will still each carry the same charge Q as before. Opening switch A leaves them isolated from any flow of charge. However, the charge Q that originally resided on C2 alone will now be distributed between C2 and C4. Since C2 is the same as C4, by symmetry, we will have a charge Q over 2 on each. And the voltage across C2 and C4 will thus be half the original voltage across C2. So therefore V1 equals V3 equals 40 volts and V2 equals V4, which is 20 volts. Many of you have that also correct. C is a little bit more problematic. With the capacitors initially uncharged and switch A open, closing switch B does not provide a potential across any of the capacitors, for the circuit branch containing the battery is effectively disconnected. All right. Fewer people have C correct. D was the most difficult. And only about, I would say, 30% of the people have D correct. Now we close switch A. With switch B previously closed, the circuit is as shown at the right. The effective capacitance of C2, C4, this one and this one, parallel combination, is C plus C, it is 2C. The entire 4-capacitor system has an equivalent capacitance, which is given here, which is 2/5 C. And thus the charge drawn from the battery and onto each of C1, C2, 4 and C3 is Q prime. C equivalent times V is 2/5 CV. Now we can determine the potential differences across the various capacitors. V1 equals V3 equals 2Q prime over C equals 2/5 of V is 48 volts, and V2 is V4 is Q prime over 2C is 1/5 V, is 24 volts. Only about 10% of the people have this correct. So maybe it was a little harder than a high school problem, I'm not sure. All right, we'll leave it with that. This is a pure capacitor problem, the only one I think I've ever given only capacitors. It's now Thursday, the weekend is coming up, it's freezing cold here in New England, northeast coast of the United States. I hope it's not so cold where you are. Since most of my viewers are in India, that will certainly be the case.